Hello, nerds. Time for part 2 of asciiadventure. So in part 1, we went through the adventure class and the screen class. I shouldn't say class. There might be multiple classes in here, these two files, because remember, we're using packages. Sorry, package is a very Java-specific term. We're using namespaces. So all the code's in this asciiadventure namespace, but I've split it up across multiple files to make it easier to look at and read and to understand. So we talked about adventure, we talked about screen. Let's talk a little bit about, what do we have left? Game objects, player, and mobs. Now, in order to understand player and mobs, since those are both game objects, we need to understand game objects. But in order to understand game objects, we have to understand a little bit about the overall structure of this project. Now, a quick disclaimer. I don't know that this project has a good structure. I honestly have no idea. It may have a terrible structure. It has a functional structure, because I shouldn't say functional, that's a loaded word. That makes it seem like it's like lambda calculus. It has an operational structure because it works, but it's probably not the best structure. Anyway, let me show you what the structure is. Hey, guess what? I want to open it anyway because it's a PDF. Boom. Okay. Yeah, clearly these are Google Slides that I just exported. There's only 2 of them. So the first thing I should start with the second one first. So if you remember back from our adventure class, adventure file over here, it had this class called game, which had like one instance variable, a random, a bunch of static methods for various helpful things, and then it had this run method, which basically does all the work. This creates this really useful instance variable, which is our representation of the screen, and then it, adds walls to it and adds the player and the treasure. It has the main sort of game loop where we read, inputs from the player, so on and so forth. So like all the actual work of this project is in fact being done in this run method inside the game class, which is in the adventure file. So that's just what this note means. Now, that screen class has this two-dimensional grid, a 2D array, containing what? Well, it's actually containing, as we saw, if we go back here and look at screen, it's a 2D grid of gameobject. And remember, in C#, this is the type. We've got the double square brackets, just like you would see in Java, but this comma in between means there's 2 dimensions. If we had something like comma, comma, that would be 3 dimensions. Comma, comma, comma would be 4 dimensions. Also, comma, comma, comma sounds a lot like the hit from the 80s from Boy George and the Culture Club. Karma, 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 chameleon. Could be a comma chameleon. I don't know. Is that a thing? Do chameleons know about grammar? Maybe they do. Who knows? Moving on. It's an 80s reference. Get used to it. I'm old. So moving on. What is screen? So screen has a number of things, a number of rows, number of columns, some instance variables, but the most important instance variable that screen has is this 2D array containing game objects. So basically, game object is a base class, which we'll see in a bit. And so this grid is of game objects. What that means is everything in here, if it's null, that means that it's basically an empty square. It is of type game object, but it is in fact null, so there's nothing there. A wall is a game object, as we'll see from this inheritance hierarchy, which we're going to go through in a second. A player is a game object, a treasure is a game object, and a mob or monster is a game object. So this 2D grid, some things in there are walls, those don't move, and they're impassable. Some things in there are treasures, those don't move, but they are passable. You can walk over them and interact with them. You've also got a player, you've also got a mob. And the player's allowed to move around. In fact, you hit your arrow keys or your WASD to tell the player to move around, and the same with the mob. It just wanders around randomly. We could make a smarter mob. That might be one thing that you could do for your project. So how does all of this work? We have game object. Is it an interface? Is it a class? Everything extends it. What does that look like? Well, here's more or less what I'm going to do is can I do this? How do I, oh, you know what? Okay, wait, let me try something. What if I close this? How do I, okay, that's not what I wanted. What if I close this? Can I bring it? Okay, but how do I get it back? Terminal, split terminal. Ha! Oh shit, that's not at all what I wanted. No, that's bad. No, we don't want this. Go away. You. Right, we want this terminal. So when I close this, how do I get it back? Terminal, new, split, run. Damn it. Terminal, come back. Maybe it's under view? View, terminal, ha! Good, great. Boom, terminal, you're gone for now, so I want to have this bigger. Okay, so GameObject. What is GameObject? What's called an abstract class. What does abstract class mean? Well, it's a class that we can't directly instantiate, right? So it's a class, and it has potentially instance variables, potentially methods. It can also have abstract methods, which are methods that have a signature, so they have a return type, a name, and some parameters, but they don't have an implementation yet. Now, if you think about it, an interface is like an abstract class, except it has no data, so no instance variables at all, and only abstract methods. That's basically an interface in either Java or C#. An abstract class can have some unimplemented methods, so some abstract methods like you would see in an interface, but it doesn't have to. But you can't directly instantiate it. So you can't just create something of type gameObject. You can't say gameObject G equal new gameObject and stick in your constructor. C#'s not going to allow that because the class is abstract. So the only way to create something that's a GameObject is actually to make a subclass of it and instantiate the subclass. But because everything down here somehow either extends GameObject, like treasure wall and moving GameObject, or extends something that extends GameObject, right? You can have a 2D grid of GameObject, and everything in there is some kind of GameObject. The 2D grid doesn't have to know what kind of GameObject, right? The 2D grid of type GameObject that screen has, but it's some kind of GameObject. So this has methods, and I'm being a little bit cheeky here by saying methods. Row, column, and token are not really methods. They're really where they're basically variables, but we're using C#'s really cool syntax where we can kind of create virtual variables and sort of like create methods. You know, whereas in Java you would have like private int row, and then you would have like public int get row return row, and public int set row int r this.row equal r, or whatever. Like you would have to have these getter setter methods, which you probably would make IntelliJ or Eclipse or whatever IDE you're using, just generate all your get set methods. C#, that's kind of built into the language. We saw this a little bit earlier. We'll see this more, right? So these are actually like virtual variables. Same with this, believe it or not. This just has a set and a get. This, okay, this is actually a little bit stupid. I just realized this as I'm working. The fact, because this like has its own built-in get method, I don't need this. This is redundant. This is basically just the get version of this. That's just a, yeah, I just realized this now. I had token to take any GameObject and convert it to a 1 character long string for displaying in our text version of things. Turns out I don't need that. I could just use this, so that was stupid of me. I would fix it, except that would require redoing a bunch of stuff, so I'm not going to fix it. We also have, like, is it passable, meaning, like, walls are not passable. If you try to move into a wall, you crash into it. Whereas, like, treasures are passable, you could move over it. You could also have traps that you move over and, like, affects your health or something. You can also tell a GameObject to delete itself, and that would delete itself from its screen. This is a little bit weird, the fact that screen is in here. This is not really a method, it's really one of these fancy kind of variables. What that means is that all GameObjects, which are things that occupy one spot on a screen, actually know about their the screen that contains them. It's a little bit sloppy. To some extent, GameObjects shouldn't have to know about the screen, but that's just how I structured it because I didn't want to go through a ton of extra effort to not have it be that way. So screen knows about GameObjects, and GameObjects know about screen. That's a little sloppy, but, you know, life is hard. So treasure and wall, these both extend GameObject, and they make it so that you can instantiate a GameObject of type treasure or wall. What do these do? Well, really treasure just has T for token and is passable, right? So, you know, if you see the letter T, that's a treasure, and you can walk over it, you know, both mobs and players, and interact with it. Walls, these are equal signs, you know, so we can have, like, walls, but they're not passable. I should mention up here that is passable, the method defaults to returning false, and so, or it defaults to returning true, I can't remember. It defaults to returning one of them, and treasure either overrides it to make it passable or does nothing, and wall either overrides it to make it not passable or does nothing, depending on what the original returns. We'll see it in a second. moving gameobject extends gameobject. All it does is add a move method where you give it a delta row and a delta column. Remember, if you're in some particular location, like down here, if I'm this player and I want to move up 1, well, that means my column is staying the same. So my delta column is 0, but I'm going up a row, so my delta row is -1. This would be delta row +1. This would be delta column 1, delta column -1. Technically, this would be like delta row -1, delta column -1, but we're not really going to support that. And again, remember, this is 0, 0, because we're not doing this in terms of x, y, we're doing this in terms of number of rows, number of columns. Why are we doing this again? Well, we're printing everything with system.out, and you start printing at the top left, right? You print left to right and top to bottom. That's how consoles work. So that's why we're doing this this particular way and not trying to do x and y coordinates. I think it's fairly common to have 0, 0 be in the top left in computer science. This is not the only time you'll see it. Okay, so we've got our moving game object, which is still abstract, right? So you can't. Oh, I spelled moving wrong. Whatever. I didn't spell it wrong in the code. I just spelled it wrong in the slides. So our new method move with delta row and delta column, that just like sort of tells an object to move. And if it's an illegal move, if there's like an impassable object in the way or is trying to move off the screen or something, then telling it to do this, it'll either do nothing or it'll throw an exception. I can't remember, but we'll see. And then we have mob and player. These both extend moving game object because these things can move, whereas treasure and wall, these can't move. If you want to create movable walls, you can do that. If you want to create movable treasures, you can do that too. Player just extends moving object, so that means it gets all of this stuff up here, plus this stuff, the move, and it adds an action method, which you can do with IJKL. So that's a directional action. So you can define what that action means. It could be attack, it could be grab, it could be mine, and you could like mine through things. In fact, that's probably what I'll do is I'll mine through walls. I think that's the example that I'll show you in a second here. And when I say in a second, I mean in the third video. This is part 2, that'll be part 3. And then a mob, this also extends moving game object. It has the hash for the token, and the actual functionality of like what a mob does when it grabs the player and how it's supposed to move, believe it or not, is encoded in the run method. This is the part that got cut off down here. It's encoded in the run method of the run method of the game class, which is in the adventure file. I should also mention that the player, has its token be the @ sign. This is my universal symbol for @ sign. See, there's the A and then the circle. Did you see it? Great. Moving on. Yeah, so that's our structure or hierarchy. So when we say everything in here is a game object, these are null, which means nothing shows up. We could have had like a subclass of game object called blank, and that would just draw as a space and not do anything. I decided not to do that, and just have it be null. But that was just a design decision. Is it the right decision? I mean, it seems to work fine, but it's not the only design decision. So everything in here is a game object. These both are moving game objects. Because player and mob both extend moving game object. These aren't. These are just game objects, and then these are null. And so you can add new things that extend game object. I just want to sort of give you an idea of what the class hierarchy means. So let's look at what this looks like in C# code. So here we go, game object. So again, we're in the asciiadventure namespace. Game object. What does a game object need to know? Well, it needs to know its row and column. And again, I forget what these are called. There's a name for this in C#. You know what? You won't be able to see this, but I'm going to go ahead and Google it just to show off my Google foo. So C# automatically create get set methods. What is that called? There's a term for it. Auto-implemented properties. Properties. Ha! That's what they're called. They're called properties. Good. Not to be confused with property like in Monopoly, where you own Boardwalk and Park Place, which really calls into question the whole idea of owning things. It's a complicated notion, ownership. Anyway, moving on. So we got row and column. What we're saying here is get and then protected set. So what that means is get is public. Well, it's either public or I actually don't know what it, well, there's another question we can ask. Okay, C# default visibility. Default visibility. So if we don't, I'm trying to find blah, 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 blah. Okay, classes. The access level and struct members included is private by default. Oh, crap. Interface is default to internal. Delegates. Wow. Well, it would be nice if I knew this. Okay, top level types can only have internal or public. Well, this is complicated. Wow. The rules of visibility are complicated. What do you know? Protected, I know what that means. That means it's private, but it can be seen by subclasses. So that the ability to set row and column, we can do it inside gameobjects or in any subclass of gameobject. Get, we don't have a visibility modifier on it. I believe that defaults to what's called internal, which means anything in what's called the assembly. Basically what that means is, and I think I do it like this? No. I do it like this? No. Damn it. How do I... let me try that again. View. Oh, it's control. Okay, it's control this thing. There we go. Good. So when I do CSC, which is basically the command line C# compiler, and I say *CS, so all the C# files, that's going to produce adventure.exe. So if I look at this, adventure.exe, there it is. Now the reason it did that is adventure.cs, this is what has the main method in it, right? So I've got one main method. I didn't specify, what thing had the main method, so it looked at all the files, figured out which ones had the main method. It was adventure, so it defaulted to naming it the exe adventure. If I wanted to, I could say something like csc *cs. I think it's /out, foo.exe. No. Damn it. Is it /out? Maybe it's this /out. Maybe it actually works with a dash. Maybe. Well, anyway, there's a way to tell it what. Did it create foo.exe? No, there's a way to tell. We could look it up. There's a way to tell it what to name it, but I'm just letting it default to adventure because I like having it called adventure. Why am I telling you all of this again? Oh, right, internal. So basically, that's going to create this executable, this adventure.exe. So there's a whole lot of things in there in the namespace that are split across all these different files. All of those things can use this method because it's listed, it doesn't have a visibility modifier, so that means it's internal, so that means anything in the assembly can use it, but things outside the assembly can't. It probably should be public, actually, but I didn't think to make it public, and it's kind of too late to go back in and change everything. So I'm going to leave it with whatever the default visibility in, which I believe is internal. So anyway, we've got row, we've got column, we've got token. Oh, I set this to protected internal. Interesting. So protected means visible to subclasses, and internal means visible to everything in the assembly. Yeah, so this must default to something else, like public or something like that. I don't know. It's an interesting question. It doesn't matter because I know that this system works, but if you do run into visibility issues, we'll dig into it more. Token and then screen, because we actually have a screen. So what's interesting about all of these is, we said this is an int, this is an int, this is a string, we gave it the type, and this is a screen. We don't actually declare any instance variables. We don't have like private screen or something like that, or private int row. C# can sort of look at this and be like, oh, you need to have an instance variable that's private, that has a name, who cares what the name is, I don't even really know what it names it, and it needs to have a get method and a set method, and the set method should be protected, and the get method should be whatever the default is. So all of that, this is replacing a whole lot of Java code, and it's very, very clear what we mean when we at least I hope it's clear what we mean when we look at this. Here's our constructor. We have to take a row, a column, a token, and a screen, and then we just assign these. Now check this out. This is so cool. What we're saying, row equal row. Well, row, like, what do you mean row? What, like, is this a variable? Like, it's kind of a variable because it's public int row, but it's not really, oh, you know what? I bet this is public because it says public there. I bet that's how that works. Anyway, this looks like a variable assignment, but it's really a method invocation behind the scenes. It's calling whatever the automatically generated get method is. So it's a nicer syntax. C# is doing a lot of work behind the scenes for us. If you remember in Java, to do this in Java, you would create the private variable, and then you would tell IntelliJ to go ahead and create your get and set methods for you, and then everybody else would have to know to call those get and set methods. C# is smarter about that. We're just like, hey, I've got an int called row. Here's the situation, the visibility, and the usability of get and set, and then boom, it just takes care of everything for you. Right? So this looks like an assignment, even though it's really going to be a method call. So we got all of these boom, 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 boom. And then interestingly, this screen row column equal this. This, remember, this is so interesting what this is doing. Okay, so screen, what is screen? Well, screen is, I mean, it's of type screen, but the name is also screen. It's the special variable, the property screen. I'm going to start remembering to use the word property. Property, you know, that's like what we're doing with all of this fancy syntax in C#. So it's like a get and set method. Maybe I'll kill this video and start again. No, I'll keep going. Will I edit that out? No, I won't. I definitely won't. Am I even recording still? I might not be recording. No, I'm definitely recording. Okay. Moving on. So, right. So, if you remember from looking at screen, one of the things screen did was override, where is it? Yeah, override the bracket operation. Right, so you can assign a game object, or you can get a game object using the brackets. What does that mean in practice? Well, here's what that means in practice. So I'm saying screen, which again is my property screen. I have a getter for it, right? Get is defined, so that means I can get it. So once I've gotten it, I can then apply brackets to it, and I'm assigning it this. What is this? Well, this just means the current game object. This here is a fancy pants way of saying, when I create a game object at a given row and column that has a certain token, you know, what character we want to visualize it with, and a given screen, okay, go ahead and create the game object, and then tell the screen at the given row and column that the current game object is now there. So this does two things at once. So we don't have to like create the game object and then tell the screen in a separate line of code, listen, screen, you have a game object at this location. We just create the game object, and since we pass the screen to the game object constructor, the constructor takes care of it for us in this really cool way. There's a lot of stuff going on here. This is the getter of a property, and it's an overloaded bracket operation that's sort of assigning, and it's assigning this, which just means the current instance, which would be the current instance of game object that we're currently creating. Super cool. Earlier I mentioned this dumb thing I did where I did toToken and I just returned token. The fact that I can just return token, I can return the getter of that property, means that this method doesn't need to be there at all. There's two references to it, and I could click on this and go find them and fix it. Yeah, maybe I will do that. Huh. Maybe I will do that. Maybe I'll do that. And then I'll get the other, okay, so save that, and I'll get the other one here. Yeah, so toToken, that's stupid. I will just go ahead and make this token. Now I'll get rid of that. There's still one reference to this? Where? Oh, no, this should be saved. Gameobject.token. Right. Okay. Maybe save this. Okay, maybe I'll... Yeah, 0 references. Good. I should mention what I did there was kind of a little trick. When it said 1 reference and it was wrong, I did a space and then deleted it, so it was like a useless change, and then I saved it, which causes VS Code, which I'm using to kind of like update all of its stuff. So now I think I'm going to just block comment all of that out. I'm going to come down here and do CSE*CS, make sure everything still compiles. It does, and so that's great. Good. I'll go ahead and commit this. So you'll have video evidence that I make mistakes, but you won't have any evidence in the code on GitHub because by the time you get this, that will have been deleted. Actually, that was a good example of showing you like how I figured out on the fly that I had done something stupid. What else do gameobjects know? Well, we have this public. I'll explain what virtual means in a second. Boolean is passable, which just returns false. The virtual here means that I'm going to allow overriding of this method because I've declared it virtual. If I don't declare it virtual, the compiler complains when I try to override it, which is a little weird because Java doesn't do that. By default, all methods that aren't static in Java are virtual. We don't call them virtual in Java. We say they're instance methods, but that really just means virtual. The term virtual goes all the way back to C++ and probably other early object-oriented languages. It has to do with dynamic method dispatch. Yeah, I don't know how. I'm not going to get into tons of detail about that, but there's historical reasons why we're calling this virtual. Virtual means it's a method that can be overridden for our purposes. So this does default to false. So if we go back to our this thing here, if is passable is false means things are not passable. Walls, since they're not passable, they don't override this method. Treasures, since they are passable, would have to override this method and change it. So that's what that means. ToString just returns the token. That's pretty easy. So this is just like if we want to convert a game object to a string, and again, this is an override because we're overriding the ToString method that we inherited from, I don't know what the root of everything is called in C#. Probably object? Let me just ask the internet. C# object equivalent class inheritance. I don't know. Let's see if that finds it. Inheritance in C#. This is way too complicated. What I really want to know... Okay, Java... that's not what I wanted. Okay, Java object, C#, what? It is just called object. Okay, so they literally just called it object like they do in Java. Okay, that's good to know. So, so this ToString method we're inheriting is actually coming from object. Delete, this is interesting. This is telling us like, hey, I want to be able to delete game objects. So if I call this delete method, that tells the game object to tell the screen that the thing at your given row and column is null. So it doesn't actually like delete in the sense of like that it makes the game object go out of scope or that it makes the game object get garbage collected. This isn't anything about delete like in the new and delete or malloc and free C++ sense of memory management. This is just telling, you know, like I need to be able to tell a game object to tell the screen to get rid of it, you know, to set it to null so it doesn't get drawn anymore. So that's the basic class for the abstract class for gameobject. Now, what do we have for a moving gameobject? Well, a moving gameobject, well, it extends a gameobject. This is how you do extends in C#. I got to show you some cool stuff here. So we need to declare a constructor, moving gameobject. Okay, we've got a row, column, token, and screen. And what I want to do is I want to call the base class constructor or the super constructor. In Java, what you would have to do is like put super as the first line of the method. That was always really confusing in Java because you're allowed to make calls to the base class constructor. Base class constructor means if you have a class that you're extending another class and you want to write a constructor, sometimes you want to call a constructor that you inherited from the base class. So in Java, you call that with the keyword super. The problem is you can only do that as for security and type safety reasons as the first, and actually thread safe reasons, as the first line of the constructor, which is very confusing because you might write some other code like a print line or something like that and then try to call super and the compiler blocks that. So in C# they were like, they wanted to enforce the same rules but have a better syntax. So to call a base class constructor, you define your constructor and then you just do colon, you know, which base class constructor. You use the word base instead of super, and then you just fill out all the keywords. All the parameters. And so this happens, this has to happen before the brackets. Then in the brackets, it turns out I don't want to do anything in the brackets, so I just have open, close brackets. I did try to not have these brackets, and I don't think that's syntactically allowed. I couldn't get it to compile, so I just have open close brackets. So this just says I want to be able to have a moving GameObject constructor, and I just want to call the base class constructor the regular GameObject constructor. So that's all fine. What cool methods does moving GameObject have? Well, it adds this move method. What does the move method do? Well, given a delta row and a delta column, it computes the new locations, new row and new column, by just adding these together. And then this actually returns a string. I can't remember why. I returned a string in case, like, when you run into a wall and it, like, tells you can't move, it returns a string. And so you could, like, print out the string or something. I don't think I actually do this at all anywhere. So basically what I'm saying is, like, okay, if, and again, this is a property access. This is using the get of that screen to get our screen. So if the new row in the new column is not in bounds, just immediately return an empty string, right? So I tried to move to some place that wasn't in bounds. So I tried to move off the screen typically. Just go ahead and end this method and return. I could have made this void and just done a return without the double quotes here. I don't think I actually return a string that's very useful here. Anyway, design decisions. Otherwise, if we didn't return and somehow end here, we know that new row and new column is a legal square, you know, that's in bounds. Now, it might crash us into a wall or something, so what I'm going to do is, again, this is both using my property for screen, and then also the fact that screen has overloaded the square bracket operator. Check at that new row and new column, right? What's there? Well, it's going to be a game object, so just get the game object. What are the possibilities? Well, either the game object is null, in which case it's just an open spot and we can move into it, or the game object's not null, in which case I got to look at what I've run into. Is it a mob? Is it a treasure? Is it a wall? Is it passable? And so on. So if it's not null and it's not passable, right, that means I've, what does that mean? Let me think. Not null, so that means it isn't null, so it's like a treasure, say, and it's not passable. So passable would be a treasure. It's not passable, so passable, not, okay, yeah. Yeah, this would be something that we can just run into. Oh, and also I have some comments here. How to handle other objects. Well, walls stop you, objects could be picked up, people could be interacted with, some things may also move, IJKL, etc. Shout command, I don't know. These are possible things you could do. Right, so basically what this means is I ran into something, so it's not null and it's not passable. So, a wall. So I crashed into a wall. What do I do? Well, I don't know, I ran into a wall or something like that. So I just returned this to do handle interaction. So I'm returning this string. It doesn't do anything. I don't even think it prints it. But I'm leaving a spot here. So you may want to check, what did I run into? If it's a wall, maybe you return the string ouch and print it or something like that. If it's not a wall, if it's like an enemy, maybe it kills you. If it's a treasure, maybe you pick it up and add it to your inventory. So you could have a bunch of stuff in here to be like, okay, what game object was it? What type was it? And what do I want to do with it? So if I'm out of bounds, I've already returned. If I've crashed into an impassable obstacle like a wall, I've already returned. So this means it's a legal move. It means either it's an object but it's passable like a treasure, which you can just walk over, or it's null, meaning it's just an open spot. What do we do? Well, I'm going to get my original row and column. I'm just going to create local variables to remember those. Then I'm going to reassign these, right? So this is again calling that essentially set method for GameObject, because I'm assigning to row and column, but these are these properties. Then I'm also going to tell the screen, like, okay, at the original row and column where I used to be, that's now null, and the new row and column, that's where I am now, that's now this, and then just go ahead and return this empty string. So you can see the string I'm returning doesn't really do anything. You know, I don't know, I was doing this in a rush just to try to get something interesting put together for this class. Maybe we'll never use this string, who knows. Anyway, that's a moving game object. It has this move method which allows objects to move around on that grid. Now here we go, wall, check it out. Wall what does a wall do? Well, it extends gameObject. Here's our constructor. We call the base class constructor, and all walls just have equal as their token, right? So instead of, for our wall constructor, remember, like for a moving gameObject, we have to pass a token. Why do we need to pass a token? Well, there's different kinds of moving gameObjects. There's, because there's going to be different subclasses, so we need to have an ability to set that. Down here for walls, if we want to create a wall, I just need to know the row, the column, and what screen it's on. I don't need to know anything else for a wall, right? Because all walls, this is just hard-coded in. This just calls the base class constructor, row, this row, column, this column, screen, this screen, what string, there it is. I'm just hard-coding it in. And since the method is passable, returns false, and walls are not passable, boom, I'm done. We get down here to treasure. What's going on with treasure? Well, treasure extends gameObject. Same thing down here, row, column, screen, hard coding in the T, but we're going to override as passable to return true because treasures are passable. You can walk over them. Because we did so much careful work with gameObject and movable gameObject, well, really just with gameObject, and because so much of screen handles like bounds checks and things like that, it's actually really easy to implement wall and treasure. And it'd be really easy to implement new things if you want to have pits you have to jump over or traps that you walk over that damage you. I don't know, whatever you want to do, you can do that. So that's essentially gameObject, and if we go back over here, gameObject, treasure, and wall. That still leaves us with moving gameObject. Oh, which this also has moving gameObject in it. We still have to see mob and player. Mob and player don't have as much stuff in them, but I'll show you what they do have because we did so much work in gameObject. So let's look at player first. So player extends moving gameObject. We have row, column, screen, and name because players need a name. And so if you check this out, we call our base class constructor row column. The player, we just want to use the @ sign, so we're just hard coding that in, and we need the screen that's part of, which was part of passed in. This name, what are we doing with this? Well, this is the parameter we're passing in when we create a player, but this is another one of these properties where we again have a protected set, and then we have this public get. So this is creating a variable behind the scenes that we can't see, and is providing us these, access methods, and then boom, name, this assignment, what's it assigning to? It's assigning to this property. Boom. We're overriding is passable to return true. Why are we doing that? Well, that's because player moves first, and if you move into a position where a mob might move onto you, the mob can move onto you and then kill you. Players also add actions. Actions are what you get with, so WASD moves and IJKL actions. What do the actions do? I don't know. You could talk to the thing in that direction. You could attack the thing in that direction. You could mine the thing in that direction. You could have settings where you like set me to mine mode and mine the thing in that direction, or set me to crafting mode, and I don't know, whatever you want to do. It's up to you. You can do anything. I should turn on a light. I feel like I'm not properly lit up here. Come on, light. Is that better? Yeah, that's much better. It's the middle of the day. It's like 3:40 in the afternoon. Oh shit, it's 3:40. I gotta go. I got another meeting. Okay, action. Well, what does action do? I'll just finish this real quick. Action is again a delta row, delta column. This is very similar to move, except if we try to do an action to something that's not in bounds, it just returns nope. And if we try to do an action to something that's null, so do an action to an open spot on the floor, it just tells us negative. Otherwise, we're going to interact with an object, right? Because that means that the object in the location we're actioning towards with the player, there's something there. Could be a wall, could be a treasure, could be a mob, could be a bunch of things. So if it's a treasure, we're going to delete the treasure and just return, yay, we got the treasure, right? Because action returns a string. Otherwise, we're going to return ouch. Why are we returning ouch? Oh, that means we will have, that means we will have, like, run into a wall, right? Because if it's not in bounds, it says no. If we try to action, this means we've, like, tried to action into a wall. So that would just return ouch. Yeah, so that's just all that action does. Cool. And again, this is made easier because we did a lot of work in screen for doing bounds checks, and because we have this nice structure in screen where we've got, everything is a game object. And finally, we have mob. What does a mob do? Well, mob is just a moving game object, row, column, screen, because mobs we're representing with a hash sign. There we go. Oop, what is that? Call from Nebraska. I'm going to not get that. Go away, call from Nebraska. Yeah, and so that's all we need for a mob. And remember, all the logic of how mobs move, if you can think back that far to Adventure, which is our main loop here, this is where all the mobs move, right? So this is actually all the, to the extent that we have any logic in the mob, this is where the logic, so the mob doesn't move itself, it sort of gets moved here. So you might look at this and be like, Spacco, your structure sucks. Like, there should be some way for mobs to decide how to move inside here. Yeah, that's fair. You could do it that way. I just didn't. The simplest thing was just to be like, you know what? I have all these mobs here, and this is actually sloppy. Just to return to this, like this screen, the fact that it's a local variable inside run, this should really be an instance variable. And game should have a constructor where you tell it the number of rows and columns, and I don't know, whatever else. Like, this is actually not great. This is just like a glorified main method, really, where you like create all your stuff. But, you know, whatever. I mean, it's not perfect. I'm showing you, like, this is not the worst design code you're ever going to see, but it's not really the best either. It's fine. So anyway, we got this list of mobs, which really just contains one mob. We could add more. We could put them in random locations. You know, I don't know. We could have different kinds of mobs. Like, you could have zombie mob and, you know, cow mob, and cows maybe are nice and healthy and happy, and zombies are evil and try to kill you. Or maybe the other way around. Maybe the zombies are really helpful and the cows are evil and try to kill you, and it's this like really perverse metaphor for, you know, the industrial capitalist society where workers are zombies and where the food production system is actually dangerous, and you know, every vegetable that we try to cook with gets recalled because of E. coli and whatever else. I don't know. Anyway, this is where the logic of how to decide where to move the mobs actually happens in here. So again, it's a little bit sloppy where the interactions are happening, but that's basically the entire project. So I'm going to stop this. The next video, what I think I'm going to do is decide that the action is mining, and that you're allowed to mine walls and they turn into something or something like that. I don't know. Or I'll do something. I'll implement an action. I won't commit that code, but I'll implement it. Okay, gonna stop this video now.